Alright, a quadratic function with x-intercepts 3, 0 and -6, 0 and has a y-intercept of 0, -5. It tells us to write an equation. Add that to yours. Let's go ahead and give ourselves a visual. Let's graph this. I'm predicting less 3 on the right side. I need more space on the left side because it has -6. (3, 0), -6, 0, and 0, -5. Some characteristics of parabolas or quadratics you should know is a probably not going to be fun. That's not going to be fun. Let's do it anyways. The midpoint between -6 and 3, so this is 6, this is 3. 6 plus 3 is 9, and 9 divided by 2 is 4.5. So 1, 2, 3, 4.5. This represents the midpoint. And I'm going to put a dotted line here. This is kind of like our axis of symmetry. And what I'm doing here is I'm just giving us a visual of what to work with. Well, since it has a y-intercept here, that basically means that the graph has to open up. And it's going to be lower than the y-intercept because it was symmetrical, is what you learned in Math 5. So my graph's going to look something like this. Okay? So how do we write an equation? Well, in quadratic functions, there are 3 different forms. There's standard form, which we learned yesterday, vertex form, and this one has x-intercepts. So they call this one factored form. Everyone say factored form? This works with as many x-intercepts as you have. X minus p, x minus q. And if it was a trinomial, you would add another x minus r, and you can just keep adding letters, as many x-intercepts as you have. Okay, the first thing I'm going to do is we wrote down the formula. Check. The second thing I'm going to do is I'm going to substitute in my x-intercepts. My x-intercepts are 3, 0. So the p and the q here represent one of the x-intercepts. I'll put that for the p. And the other x-intercept represents the q. So p is 3. And my other intercept is -6. Now I can bring down the parentheses, and you can also include the minus sign. Alright, so we wrote down the formula, substituting our x-intercepts. Let's now substitute in the other coordinates. Now the other coordinates that they gave us is this one. They gave us a very special point. Y-intercept is 0, -5. So basically my x-coordinate is 0 and my y-coordinate is -5. That basically means for every x value we're going to put in 0. And And every y value, we're going to put in negative 5. Remember, f of x is just a fancier way of saying y. So my y value is negative 5. Now this is going to be kind of weird. Every x value is going to be 0. And basically what we need to do next is we need to solve for a, solve for the a value, and then write our equation. So here's our a value. Let's go ahead and solve for that. You'll notice that all the other variables go away, and then you can just solve for a. So I have negative 5 equals a times class 0 minus 3, negative 3, 0 minus a negative 6, 0 plus 6 is a positive 6. Remember here you have multiplication and multiplication, so negative 3 times 6. To get rid of the negative 18, should I add or divide? Divide. These will cancel, so that equals 1. And a is equal to positive 5 over 18. So we just solved for a. What do I do with this a value now? Well, basically, we're just going to substitute it back into the equation. And we basically put it there for our a value. Now, an equation always has f of x or y, so you can choose. Our a value is 5 over 18. And then all I have to do is write in the substitution x minus 3. Careful, this one's going to be x plus 6. And this is our answer. Here we have a polynomial here, a quadratic function. You can quickly see that it has a x-intercept of 3, negative 6. A value is positive, so it opens up. And we just used factored form.